All right, so while SolidWorks loads up on my computer, we can go ahead and take a look at what the project is. So for part one, we have to get the velocity and pressure contours at these different points or angles of attack. And we also need to get the coefficient of lift and drag versus alpha as well. Getting all of your data using Fluent. And then for part two, we're going to be doing almost the same thing, but with a horizontal plate. With the dimensions here, 6 inches by 0.1 inches. And then the velocity that the air is moving at is going to be different, so 10 and 15. And for the plate, we have to get the velocity contours zoomed in, get the local skin friction and Reynolds number and kind of plot them up against each other, get the drag force, and then compare it with the theoretical. And then find the boundary layer and compare that with the Blasius velocity profile. So let's start with the plate because I already have it pulled up. So with your geometry, you can go ahead and right click. It should pop up a little window for you and you can select whatever geometry you need. So I'm using the plate for the first one. So obviously ours is going to look like a plate. Takes a minute to load on my computer. Give it a second to load. So the easiest way that I found to do this is to go into SolidWorks and just draw your rectangle. And then here it is. So once you go into SolidWorks, draw this thin rectangle. And if we go ahead and look at our sketch, you can see the dimensions. So 6 inches, 0.01, and I centered it since the entire rectangle is 12 inches, 3 inches in the front, 3 inches in the back. And then I just picked 6 inches to make it a nice 1x2 rectangle. And when you're centering it from top and bottom, just keep in mind that 0.1 thickness of the plate. So you have to change this value. And then you can go ahead and exit. And if you look at it, I actually have something different here. It's called the surface plane. And you actually need the surface plane in order to have Fluent recognize it. So to do that, you're going to go insert and then surface planner, and it does it for you. So then you can go ahead and file, save as. I won't go through the whole thing, but you're going to find this one, IGES. And you just save it as that file. Something easy. Mine is part one, but this was just my example. So we can go ahead and close that. So we just go ahead, right click, replace, and then you can browse part one. I have a plate, 15 degrees, all of that. You can see this is my SolidWorks, and this is that IGS one I was talking about. And I can actually go ahead and close that. If you do double click on geometry, it'll actually open up a mini SolidWorks. I don't want to say mini, but just I guess a less used. If we go over to mesh, go ahead and say edit. All right. It pulled up on my other screen, so just give me a second. All right, so this is where you go and you edit your mesh, or create a mesh if you don't have one. So the first thing I normally do is I make all these name selections. So they're kind of like relations for you to go back and reference and use again. So if I click inlet, it's at the start of my essentially test section. And then here's my plate that's going to be tested. We have our output, top surface, bottom surface, front, back. You can select the whole thing as one. I just decided to do top and bottom. That way, if I wanted to get individual results, I could. And then I named this one symmetry because you have a top and a bottom and they're the same. So we can go ahead and close that. With our mesh, how we're going to do this is go to method. We're not going to use automatic. What we want to use is first we have to select where we want our mesh. So it's going to be that giant area. Apply. We go over here, triangles, mesh. And then I'm going to change the element size just for now, because my computer will have a seizure. So generate mesh. It's going to be super fast because of how large the rectangles are. 0.5 is probably a little too big for me to put, so let's do 0.05. Maybe a little bit more of a realistic mesh for us to work with. Yeah, that's okay. Really big mesh, not ideal at all. You do want to try to get the mesh as small as you can. So once we have all of this set up, we hit generate. You can go ahead and exit out of this. I'm going to minimize it because I'll need to pull it up in a second. So then you just go back to mesh, update, should update in here. There we go. Our mesh is set up. Now we can actually set up the experiment. So we go to edit. I actually had this one already pulled up, but it seems like it got rid of everything when I was doing everything else. So if we go over to models, it's going to be closed. Make sure that what we're using is a laminar flow, and you can go ahead and change it here. They have a bunch of different types, but that's not what we need. So then make sure you're using air as your fluid. If you want, you can go ahead and change all of the different properties. You can even put in your own formula, but again, we don't need to mess with that. For inlet is the next important part of it. So since we're doing the rectangle, we need to make sure it's at 10 meters per second. And then we can go ahead and hit apply, close. All of these should be fine. The only other thing I would look for is that your output or outlet, whatever you name it as, is an outflow. And it's not registered as a wall, because then you'll get back pressure and everything else. All right, so the next thing is you can call different reports. So I had these for my airfoil when I was doing them, and I'll get to this later on. We don't really need it for this part. So then we can initialize it. Boom, just keep it at hybrid. You can see down here, it's kind of going through the process. And then run calculation and calculate. So the data here is probably going to be very rough, just because of how our mesh was. You can kind of see how it goes through it. We do have 100 iterations, so it's going to do this 100 times. So while we're waiting on that, I can kind of discuss some of these things. So for part of the project, we needed to get 2 different data sets at the middle and at the end of our plate. So to do that, we have our endpoint and our midpoint. To do this, you can click your mouse if you want. You can input the numbers. What I ended up doing was converting 6 inches to meters, taking half of that for my midpoint, and then just leaving it for my endpoint. You do that for both of them, and I don't think it'll mess it up if I click. It won't let me. But essentially, that just creates a reference point for you to look at. makes it a little bit easier. So there's our velocity contour, a couple other things in here that we'll go over. Still doesn't want to show me. There we go, display mesh. All right, yeah, let's see everything, nodes, edges, faces, display. No. Display. Well, it doesn't want to display there. So endpoint, we have them in here, minor negative just because of where my origin was. It's going to be the same thing for the midpoint. You change these values. When you click on it and you hit new, you're going to go to line and rake. You just need to use a line. And then for graphics, this is where we can get some of our contours. So if you look at this, this is our test section. That's where our lines are, our reference lines, and then this is our inlet. This looks a little weird right now just because of what we're looking at, or the amount of nodes we have. So let's look at static pressure, display. All right, we can kind of see how it's acting. The more nodes you have also, the better this will look. If we go to velocity, display, you can kind of see the velocity. This is similar to what we're going to get later, but we're actually going to go to the results section to get that. And then just make sure you have everything selected. Let's say you wanted only the bottom surface. You can kind of get rid of everything, display, and it's just going to show the top. But not much more than that. So then we can go to our XY plots where we're going to get the majority of our data. And so with these, we can actually go ahead and what are the different ones that we get? So that's in the next part. All right, so we need to get skin friction coefficient with respect to the Reynolds. So we can't really get skin friction to Reynolds in here. It looks a little weird. So we're going to go ahead and get skin friction relative to the X position. And then we'll go and calculate the Reynolds number from that because we'll have our location. We can just take the area up to that location and calculate it that way. And then we can also get a more accurate velocity up to that point. So I'll just go ahead and show you our skin friction and with respect to the x-axis and then direction vector, go ahead and say all of it, save and plot. So here we go, we kind of have it. Some of these you'll see, like if you just hit all of them, you're going to get every set of data. If you hit just one, so just the bottom surface, save and plot, we get just the bottom surface. So that's really helpful. If you need to, you can click that and you can actually do, say, let's go here, UIDX, and then velocity, and we'll hit midpoint. So you can kind of see the velocity based on that derivative. All right, so now that we have all of that data, we can find all of it. We can go ahead to our next part, which are going to be our results, just update solution. So I ended up stopping this. What I'm actually going to do is I'm just going to open the project that I already had. It's going to be easier to understand. Do you want to save it? No. It's going to be easier to understand, and it's also going to give a little bit more insight, be a little bit faster. So let's go ahead and get that loaded. So what it's doing right now is just kind of reverting everything that I just did, pulling it back up. And look that we can see everything's already checked. Results, edit. And this is going to take a second, but it'll take us to the results page where we can get a little bit more information. A little bit cleaner graphs, stuff like that. So yeah, this is also where we'll get our velocity, contour, and vectors graph. You might be able to do it in the other section, but I just prefer this method. See if it loads in with them. All right, it did. All right, so we're looking right at our graph. This is going to be our velocity, vector, and contour. So if you look over here, I click this, we kind of lose out on some of those vectors that are going and showing how much force there is. And then if we don't have that, we have nothing. Maybe a little bit better interpretation if you see it like this. Head on. So you can kind of see how it's moving around. Then if you click the arrow, it'll center you back out. And then now that we have those, if you want to create them, you're just going to go up here. And then I'm going to say contour 2 because I already have one. The locations you want to look for, I had to go with symmetry 1. And then your variable, you can check the different ones. So we can hit a velocity and get that. And then number of contours, I said like 100 or something. I just put a big number. That way we get a really wide range. And then with each of these, you can kind of see what applies. Apply. It'll go and do its work. If we had hit pressure, apply, it'll go and show you the different pressures and kind of how it goes back. Vectors, we already went over. So those are what you need for part 1 in here. And then we already talked about the skin friction. You're going to go do that in Excel. That should be pretty self-explanatory. And then with your CD, I did not talk about. So I'll do that really quick on how to get it. And then with the boundary layer and Fluent, it's going to be using the XY plot from before. So let's go ahead and exit out of results. Go to setup, edit. And when you pull it back up, it's already going to have the 100 iterations already done. So we don't have to worry about running it again. But if this was something new, you're going to have to initiate and then run the 100 or however many you need. Let it load. So you kind of get a small report of how many nodes you have and zones and all of that. Still loading. But it has it over here for us right now. So this is what mine looked like before. You can actually see how much smaller they are. You are limited on the student version, so we can't get the maximum amount, but this should be plenty for a plate and what we're using it for. So if we go down to plots, no, graphics, no, where is it? Oh, do I need to run it? Boundary conditions, flow, good. Inlet, time applied flows. I want to say I already had all of these run, but we'll go ahead and do this. Run calculation, calculate, and there. All right, so it did restart for me this time. So we'll go ahead and let that run, and now we can see we have our additional plots and contours and all of that we didn't have before. So let this run. Hopefully it'll go quickly. With the XY plot, you're gonna go ahead and right click on it. And I'll just pull up a random chart, show you how to save it, and then you can take that data into a text file. And then from that text file, you're gonna go ahead and put it into Excel. Almost done. All right, there we go. Calculation is complete. So we can go down to our XY plot. And I'm just going to do something super simple. So let's do our velocity. We need to see what it will kind of look like anyways. So why not? Let's go ahead and get all of them. So if we just hit save like I just did, it's just going to show us this type of graph, right? But if I go down and I say write to file, you now see that there's no longer a visual option, right? So it's just write, and it has the file directory. I'll name it test1. Enter, it'll save. If I go ahead and I pull up that test1 file, complete. Is it going to be in here? Not in here, but here are some of the ones that I had before. So we'll go ahead and look at stream velocity. Again, you can pick anything. I like using Notepad and then transferring it. It lets me kind of see the data before I go ahead and open up Excel a little bit faster. So that's how you can pull some of the data for your Excel needs. Contours I already showed you. Calculation, already did it. This will come back to in just a second. I'm going to go ahead and pull up the airfoil. All right. So going back to here, we covered our contours. We got those. We know how to get our skin friction coefficient and our local Reynolds. The drag force we do need to get. I'll get that with the airfoils to show you. Plot the boundary layer. We already did that. So we know how to get our plots. So the next step is going to be using this machine, which is going to give us our airfoil. So we need a 2415. So 2415. Number of points we can change, let's say 140. Plot. So now we can say send to plotter. All right, we have this, and what we can actually do is change the pitch or the degrees for our angle of attack. And we can do this when we're going into SolidWorks. That way we can change it, and then we'll import it into Fluent. So for me, I'm just going to say 0 degrees. Make it nice and simple and easy. So go up here, CSV file. You can see I have a bunch already. So we'll go ahead and hit save. You can open it. If this opens fast enough, I'll go ahead and show you. Well, while that loads up, I can show you what to do on the SolidWorks side. So we're actually going to go into our sketch and we need to edit it because we don't need this rectangle anymore. We can get rid of it, no longer of use. So trim entities, just get rid of it. Color around. Done, done. Look at that. All right, so our Excel sheet just popped up. We have our airfoil surface. We can follow all of this. The only modification that you need to make to this, you see we have our 140 points, is you have to connect it back at the bottom. So look at whatever point we have at the top, copy and paste it to the bottom, and add a bunch of zeros because we're going to have this be our X or our Z direction. So we can go ahead and exit, or I can show you. You need to go to File, Save As, Browse, find wherever you want to save it. And then what we're going to do is actually save it as this one. So as a text file, you can see I have a few already. And so that's what you're going to do. And then insert again, just like we did for our surface, but this time it's going to be for a curve. You need to exit the sketch. Insert, curve, curve through X, Y, Z. It's going to come up with this little thing, browse, and then airfoil. You're going to have to change it to show text files. And then here's my NACA 0 angle of attack. This one's in inches. It'll make it easy to read since this is already an inch. Actually, no. We need our millimeter one. There we go. So this is in millimeters. Go ahead and open. We can see it has all of them here. Go ahead and insert, hit OK. Not going to show it to us. Delete. Yes. And then normal to. Delete. Yes. We're just going to go ahead and make ourselves a blank canvas. And we're going to change this to millimeters. So again, insert, curve, curve through XY, browse, go ahead and find whatever we need. Text files, this inches. Here, this one's in millimeters, so open. This one should be good. Starts at 1,000, ends at 1,000. Okay. I think it was this one I needed to go ahead and delete a line. Yeah, because there's a duplicate. Insert, curve. There's our duplicate. This one doesn't have the duplicate, so we'll go ahead and use book 2. And then, okay, boom, normal 2. Let's go ahead and zoom to it. I don't know why it's not showing up. There we go. All right, so we have our airfoil. You can see it's closed at the end because we made it connected. So what we can go ahead and do now is sketch, front plane, And we're gonna draw a rectangle around it. This one's smaller just because I'm showing you. And then insert surface, plane, current sketch, check there. But what we want to do is have this airfoil go through. So we can actually go ahead and insert surface, planar. This guy, check. Should have gone through. How did I do it before? Delete. Yes. Sketch. Edit. Okay, I know why. Sketch. Let's get rid of these. There is probably a hole somewhere. This needs to be a solid piece without any holes or anything like that when it's coming through. What I also did was I found the center of this line and I went ahead and made it adjacent to that, or not adjacent, but horizontal. That way they're always in line. But I don't know why this doesn't want to show. Good curve. Edit feature should be completely closed. Well, you need to have it completely closed. There's got to be a hole somewhere on mine that's not allowing me to use it. But I can go ahead and get rid of this and I can pull it up in here and you can actually see it all set up. So geometry replace. These are my different angles. So if we browse, we can go ahead and see new folder, IGES, airfoils, 10, 15, 20, 0, -5, and +5. So like I said, we're just going to do this one, open, mesh, edit. All right, so we got to read it again. Let it load. So, and you're actually going to see this update really quick and go from the rectangle to the airfoil when it's done loading. Geometry, replace, NACA, edit. I found our airfoil. So if you look at it, you can actually see there's a hole in the center. That's what we needed in SolidWorks, but it wanted to give me issues. So we're going to go ahead with this one. If we looked at our name selections, we actually have all of the ones from before. But the only thing is we don't need them now, so we can go ahead and delete a bunch, such as all the surfaces. Yeah, we can delete front and back. And those we can keep. These we can get rid of. All right, so whenever you have to remap them, go up here, select edges, and then right click, and there's going to be this little arrow, and whatever you click, it'll make it that. Symmetry. I don't know why it's not doing this one. All right, well, if it's not doing it, you can just get rid of it and then remap it. Create new, do based off size, and now we have top and bottom. For mesh, same thing, insert method, apply, or we have to click the center, apply, and then we're going to go ahead and do triangles, mesh, generate, and we have, this is our element size. So it's kind of small. This is actually going to take a minute to do. So what we're going to go ahead and do is change it. So if you need to, this little thing will pop up, just hit stop. And then element size, we're going to change to 0.001. That shouldn't take too long, and the contours will be a little bit nicer. So go ahead and generate. All right, so it should be done any second. And then we'll be able to see our perfectly meshed up airfoil. Yeah. Oh, I know what's wrong. So the one thing we forgot to do here was mesh. One of the most important things, we need to also, or not mesh, but select our airfoil. So we need to have an airfoil. So that was my bad and part of the reason why it was taking so long, I'm guessing. I was trying to figure out how to mesh around there with nothing. All right, so this generates a new mesh. It doesn't give us any problems. So we can see our mesh is done. We have all these little points that are going to collect data for us. So just save it, and then it'll automatically upload to the next part. Mesh, and then update. All right. Set up, edit. Yes. 2D, all this can stay. Load. Will take just a second to load up. There we go. All right, we can see how many zones and all that we have. It'll finish loading and then we can actually start to change things and then run our simulation. You should be able to get all of your contours on here. It's the vectors that I don't know if you can. Okay, so to generate. So models, make sure you have that laminar flow. Materials, fluid, we're going through the air, boundary conditions, inlet. This is something we need to change because we're now working at 15 meters a second, not 10. So change that to 15, apply, close that up, make sure your outlet is truly an outlet. Close that. Boundary conditions, output is an outflow, good, inlet is a inlet. And then we have our airfoil that we're going to be using. Go ahead and close that up. We can scroll down to report definitions, and this is something that we didn't really have before. So go ahead and right click, new, force report, and then this is where we're going to get all of our drag and lift. So drag, pull it onto this screen, drag force, drag coefficient. We need the coefficient for this. On the plate, it might be useful to get your drag force just so you can use it on some of the formulas. But yeah, so once you have this, you go ahead and select what you want it on, and then you say okay, and then you do that again, new, force, lift coefficient. We want it on our NACA, and then okay, and then initialize it, boom. Let's start everything up. Run calculations, calculate. We probably could have done 50 just because I'm showing you, but it'll take us through all 100. And it's actually going to pull up those two, CD and CL, versus however many iterations we did. And then you can take however many simulations you do at different angles of attack, take that and make your chart for your angles versus your coefficient of lift and drag. So that's loading. Okay. So then we can go down here, graphics, contours. So that's what we need now. And then pressure, static pressure. Go ahead and just select everything you need. Just going to select everything for now. Save / display. And we can see our nice little graph. Well, let me drag it. No, it won't. And then if you wanted to, you could add in like contour lines and different stuff like that. And that might help. There we go. And then we can go ahead and change it. Velocity, velocity magnitude, display, kind of get a different view. You can really see the boundary layer, how thin it is compared to this. And yeah, so after you get that, those are the screenshots we needed. The angles and all of that, we can just go to reports, if you go down to compute, it'll spit it out right there for you. Or if you wanted to, you can go ahead and export. I just did this, took a screenshot, copied and pasted into Excel, and that's what I used. That should be everything though. So this was my final for Dr. Osbeck. And yeah, my name was Christopher Roesch. Okay. And that's it. Stop the share. Go ahead and